folks. Today we're going to look at judgment and decision making. There will be plenty of opportunities for you to pause and reflect throughout the lecture, and I will be lecturing at perhaps a speed slightly faster than usual because I recognize that you're able to pause and rewind and so on, unlike with face-to-face lectures. Okay, so here are some key terms that we're going to be looking at in today's lectures. I'll just give you a chance to pause and look at these terms so we understand them before we get going. Now here's the overview for today's lecture. First, I'm going to introduce you to heuristics, which are basically mental shortcuts for judgment. Automatic assumptions and interpretations and so on that help us make judgments. For example, will the light turn red by the time I get to it, or do I have enough time to get through that yellow light? That's a judgment that we might make, and we might have certain heuristics that lead us to making certain judgments rather than other judgments. We also have biases. These are just like heuristics. These are a type of heuristic. Heuristics that bias our judgment and decision making in one way or another. So you might be biased. You might have heuristics that are sort of biased to thinking, oh, I will have enough time to get through the light before it turns red, and your bias or your heuristic might be influenced by the fact that you're generally maybe an impatient person. You don't like waiting at a red light for too long. We also have schemas. Now, the best way for me to describe schemas would be to describe them as they're just like stereotypes, but they're not of the social world. Like you might have a schema of an office, like a stereotype of what offices are usually like. You might have a schema of how you behave at work versus how you behave at home, work life versus home life, and so on. So they're like stereotypes, but we're not talking about social groups anymore. We're talking about events or places of the world, so to speak. And then we're going to look at an example of quote-unquote social schemas, so rules that apply to the social world versus rules that apply to things outside of the social world. Anyway, that's probably a bit vague for now. You'll get the sense of it when we cover it. And then decision making. We'll begin by looking at traditional theories of decision making, which theorize that humans make decisions based on the anticipated utility of those decisions. So when you make a decision, you're obviously thinking, okay, will this decision benefit me or will it not benefit me? And which decision is going to lead to the most gains, right? Like, if I decide this job versus that job, well, which job is going to give me the most money, and so on and so forth, right? That's the traditional model of decision making. Well, updated models have looked at, have included emotion into the picture, and also some evolutionary psychological principles, because it turns out that us humans, we're actually not all that rational. We're much less rational in our decision making than you would think. So we'll explore that, and we'll also look at a theory called prospect theory, which emphasizes loss aversion. And it turns out a lot of evidence suggests that we, as humans, we fear losses more than we desire gains, and this really affects our decision making. Think about gambling or investment decisions and that sort of thing. For most of us, when we engage in these behaviors, our decisions are affected more by our fear of losing something than by our desire to gain something. So these perspectives have updated that expected utility theory of decision making. Okay, I want to start off with an example, just to get the mental juices flowing on the topic of decision-making and judgment. So let's imagine that an OBGYN is on call and is getting some patients who are in labor. And and ultimately there is one patient, and the patient is in labor, and the OBGYN has to decide, okay, does this patient need a cesarean section, or can they have a regular vaginal delivery? So a C-section is usually used in emergency situations where maybe the baby has to be retrieved from the womb as quickly as possible before something serious happens, right? So C-sections are serious. They're more and more common these days, but they are usually used when it looks like a vaginal delivery is not safe. So it's an important decision to make. You know, it's a decision that an OBGYN would not make lightly. Now, so that's the scenario we're imagining. Well, participants in an actual study were given this scenario and they had to imagine it. Now, participants were divided into they were divided up across 3 different conditions. Now, in the first condition, which was simply the control condition, the neutral condition, this focal case of this case where they had to decide if they need a C-section or not, that was presented first. That was the first thing the participants saw, and then they had to make a decision. So nothing came before that. In an experimental condition, participants saw a bunch of serious cases first. So they saw 4 serious cases that would usually call for an emergency C-section. And in the third condition, the other experimental condition, participants saw 4 non-serious cases first. It's cases that usually would not call for a C-section. Now then the focal question is, so our dependent variable is, did participants opt for a C-section in this focal case, yes or no? So it's a simple binary or dichotomous dependent variable, yes versus no. And we want to see the decision making, the rates of choosing yes versus no in each of these 3 conditions. So just pause for a second and think to yourself, which condition do I think led to the highest rate of C-section decision making? So in which condition did which condition led more participants to choose a C-section? Have a think about that. Okay, I will reveal the results to you now. Here are the results. So participants who saw non-serious cases first, they were much more likely to recommend an emergency cesarean section. Now, many of you were probably thinking, oh, if I see serious cases first, well, that's going to prime me to think of serious cases. I'm going to be primed and my mind's going to be activated to think about the option of C-sections and so on and so forth. It's a plausible theory, but it turns out that theory wasn't supported. Instead, another theory was supported, and that theory would say that we often make decisions by looking at contrasts, by comparing, this case versus a previous case that we saw. And when you see a bunch of non-serious cases first, that might change the boundaries and the thresholds that help you decide what's serious and what isn't. So the test case that all participants are judging, when that test case is preceded by non-serious cases, well, that test case is going to seem a little bit more serious now. But if that test case was preceded by serious cases, well, relatively speaking, that test case is going to seem relatively non-serious, right? So this research helps suggest that human decision-making is almost never performed in a vacuum. We are always judging stimuli or judging decisions or options and so on relative to other decisions and options that have come before it, even if we aren't even aware that this is what we are doing. So that's just one example to get the ball rolling with decision making and judgment. Let's look at some other examples. Framing is a really important topic that we'll cover. How do we frame decisions and options and choices? How do we present them? Let's have a look. So for example, in America, 85% of the public approve of, donating their organs? Say you die in a serious car accident or something like that. Do you want your organs to be donated to scientific research or to save the lives of people in need of a donation, and so on and so forth? Most of us agree, yeah, that's a good thing, but only 28% of us are organ donors. Turns out in America we have what's called an opt-in procedure. By default, you are not in the program. You have to volunteer and say, yes, I want to be an organ donor. Right? I updated my driver's license recently, and that's exactly what I had to do. I had to remember, oh, I want to be an organ donor. Okay, I'm going to have to tell them that, because otherwise I'm not going to be in the system. However, in France and Belgium, over 99% of people are organ donors. Surprise, surprise, it's because in that country they have the opposite. They have an opt-out procedure, and you have to decide whether you want to leave the system, the default setting being that you are in the system, right? So clearly, we can see, massive differences in the rates of organ donation here, 99% versus 28%, even though attitudinally 85% of Americans, support it, probably similar to the rates in France and Belgium, but the framing of the decision-making leads to very different outcomes. Do you have to decide to opt in, or do you have to decide to opt out? Okay, so that's one example. Let's have a look at another example about why judgment and decision-making matters and why framing of decisions matters. Imagine you had to make this decision, right? $2.50 to yourself, $2.50 to save the children. Now, this 6-second time limit, how does that affect your decision making? It might lead you to make the rash decision to spend $2.50 to save the children, right? Because time is pressure, and under pressure we want to go with, the pro-social, socially desirable option, often at least. Also another factor in framing this decision making, look at what we've called the Save the Children. That's the name of the charity here. If that charity had some other name, like some generic corporation name or something like that, there wouldn't be such a glaring contrast between $2.50 to save the children or $2.50 to yourself, right? So the framing of these options really affects how people respond to these options and which options they choose, right? So yet another example of framing and decision making and how we're often affected by the context and the presentation of decisions. Now, a little bit of a tangent here, but this topic is actually really important in psychological research and in any research that uses questionnaires, tries to collect data from human subjects and so on. Because let's say I'm asking you questions about trying to tap into your levels of prejudice or your attitudes towards certain social phenomena, your beliefs, your public policy views, your political views, and so on. How I frame the question is going to be really important in what answers you provide for me. For example, if I give you a 1 to 10 scale and I ask you, are you politically left-leaning or are you politically right-leaning? What happens when I change the endpoint anchors so that 1 equals extreme left and 10 equals extreme right? What if I say 1 equals very left and 10 equals very right? By avoiding the words extreme, am I now more likely to get people who choose the endpoints of that scale? If I use the words extreme, maybe people, extreme, well, that's an extreme word. Obviously, people want to avoid aligning themselves with the extreme. Maybe people who would normally say, 1 far left or 10 far right on the scale didn't do so on that scale because they weren't comfortable with the word extreme. So these are real problems and real issues we face in collecting data from human subjects. There is no easy solution to it, but it really helps to understand the science of judgment and decision making for this venture of collecting data and so on. So all the more reason that you want to pick up a few things from this lecture today. Okay, now here is an example of heuristics. So looking at these words, right, you'll look at that first line. Oh, I hope my mouse is lining up correctly where it's supposed to go. It seems to end up, so if I'm pointing my mouse at the word cat, and it's probably up here for you guys or something, so I'll try to accommodate. So if we look at that first word, we read it as cat. The second word we read as hat, even though the H in the second word and the A in the first word are the same, right? But we don't really have to think all that hard about it. It happens automatically, right? We're relying on heuristics, stored brief little summaries of information that help us make quick and easy judgments and decisions, right? Likewise, over here on the right, you see 12, 13, 14 on the vertical and ABC on the horizontal. You didn't have to exert all that much mental effort to process these stimuli correctly, because you have very reliable and very frequently used heuristics that tell you A is followed by B and followed by C, and so on and so forth. 12 is followed by 13, which is followed by 14, and so on. Sorry about this, the slide is a little bit delayed. Okay, so we rely on prior learning, right? You've learned cat, hat, 12, 13, 14, ABC, and so on, and you have expectations based on that prior learning, right? This is top-down processing. We've discussed top-down processing before. You're processing novel information, novel stimuli, right? You've never seen this picture before, I assume. You haven't seen this lecture slide before. You're processing this novel information using prior learning and the expectations gained from that prior learning. It's automatic, which is great for the brain. It's great for the mind. It's great for behavior and decision making. You don't want to be exerting all this effort every decision you make in life. It's really good to have a lot of decisions relegated to the subconscious. It's quick, it's effortless, involuntary, doesn't require as much effort, energy, or attention. Maybe it's even uncontrollable to some degree. Try reading this as 12B14 or A13C. It's awkward. It requires effort to do that. We also have social heuristics, which are called stereotypes. So it's a bit of circular definition here, I guess. I'm calling heuristics as like or rather schema as stereotypes without the social element. Stereotypes are basically heuristics for the social world. They are, stereotypes are like social schema, and these provide us with social heuristics, right? So you might have a stereotype that, for example, Australians are funny or something like that, and that leads you to certain heuristics that interpret, for example, maybe if you have that stereotype, which would be good, that leads you to certain heuristics that leads you to interpret a lot of what I'm saying as, I'm being humorous or something like that, right? So your stereotype leads you to certain information processing approaches. So sometimes stereotypes are good. The example I just gave, Australians are funny, that's a stereotype I would happily embrace. Police officers and librarians can be helpful and so on. But of course, sometimes stereotypes are bad. Obviously, I mean, this doesn't really need to be stated, but I'll just give you an example. In the 1970s, there was a study that really clearly showed the pervasiveness of stereotypes. So participants read a story about Duncan pushing another person, and when Duncan was white, it was called playful, but in other conditions, when participants read that Duncan was black, it was considered aggressive, right? So the same behavior, we rely on our social heuristics. Oh, that's a white person pushing. Oh, that's a black person pushing. And that activates all sorts of subconscious mental processing schema and heuristics of understanding what does it usually mean when I see a white person pushing? What does it usually mean when I see a man versus a woman pushing or whatever it is, right? And we interpret that information based on past learning, knowledge, and stereotypes, heuristics, and so on. Some of these can be negative, and we can often, many participants who responded it was aggressive, they might not actually be prejudiced, but they still have stereotypes in their mind that are affecting their decision making. Okay, some definitions are required. Now, as we've already kind of stumbled across, it's often quite tricky defining heuristics, schema, biases, stereotypes, and so on. There is actually a lot of overlap between these terms, and when you look up definitions online, you'll get a sense of that. But anyway, some terms are more easily defined than others. Judgment, we can simply define as the process in which we estimate how likely various outcomes will be, right? So when you judge that a traffic light will stay yellow before you get to it, right, if you want to run that light, well, that's a judgment you're making about the probability, the likelihood of certain outcomes. In this case, how likely is it that it'll turn red versus stay yellow? Heuristics, we've mentioned already, are mental shortcuts or strategies for problem solving, interpreting information, right, and so on. So an example of heuristics being used in judgment would be in this anagram below. Let's see how long it takes you to solve this anagram. And my reckoning is that you should all have developed heuristics that would help you in making a very quick judgment for this anagram. Now, if you don't get it too quickly, don't stress. Maybe you're tired or distracted or whatever. But anyway, I think you guys will do better with this example than students in other classes. You got it yet? The correct answer is psychology. So obviously, there are various patterns that we can look for that might activate heuristics. We see PSY together, and if PSY weren't together, the P was over here, the Y was over here, or something, then maybe it'll be a little bit trickier. But there's another, set of heuristics at play here, and that is the heuristics that you have developed in your mind, given that you are psychology students. A biology student might not do as well. In other words, might take longer to solve this anagram than psychology students, because you have much more exposure to the word psychology. So you have seen, the lettering and so on more often than others. So you might say that your heuristic for solving this anagram is more honed and more kind of like sharply tuned. Okay, schemas, heuristics, and expectations. So we make inferences based on schemas, right? In a previous lecture, I showed you an example of, we have a schema for offices. And offices usually have books. That's part of our schema of an office, or our stereotype of an office, if that word is a little bit more intelligible to you. Well, this is the exact same example that we looked at in the previous lecture. Participants who saw this picture, they were later asked, how many books did you see? And they guessed various numbers of books. Well, it turns out there are actually no books in this office, but they incorrectly remembered seeing books, because books being in an office is part of people's schema of what an office is. So in a nutshell, we are much worse at judgment and decision making than we think. We have all sorts of heuristics and schema and biases, some of which might actually guide us towards good decision making, but a lot of which does not guide us towards good judgment and decision making. We have a lot of biases and so on, and we'll look at these in more detail. We have a lot of unreliable heuristics. Again, we will look at these in more detail. Given that we are much worse at judgment and decision making than we think, well, let's have a look at this process and look at when we stray from sound reasoning and judgment and decision making. Okay, so again, we can define heuristics as mental shortcuts or strategies for solving a problem. So we have, first of all, what's called the availability heuristic. This is one type of heuristic. We rely on the evidence that is actually available to us, and therefore the evidence that is most easily called to mind, most easily accessible, most easily recalled and remembered, and so on and so forth. So it is available to us. It only makes sense that the more something is available to us, the more likely it is going to come into play. So we act as if things are more likely if they're more memorable. And we do this even if we don't want to do it. It's not always intentional, right? So an example from casinos would be, it's obviously much more memorable when you win. You get the jackpot and the lights are flashing and there's a lot of loud noises. The casinos do that very intentionally because that makes that experience a lot more memorable, much more emotional in its impact and its resonance with your memory and attention. And therefore, it makes it more memorable, and therefore, it makes it more available to your memory and your imagination, and therefore, it makes you think that winning is more likely than it actually is. Casinos and gambling outlets are very savvy when it comes to the psychology of human judgment and decision making, so we have to be very careful. But let's have a look at this availability heuristic. So, a classic example is, how common are shark attacks? One of the stereotypes of Australia that I'm actually quite fond of, even though I hate to admit that it's not quite true, is that Australians are all really rugged and tough because everything on our continent is trying to kill us. Now, yes, we have box jellyfish and great white sharks in our oceans and snakes and spiders and stuff in the midland and so on, but they're extremely rare. Most of where Australians live, we have very little contact with these dangerous creatures. And of course, great white sharks are nowhere near as aggressive towards humans as the stereotypes suggest. But, right, we have information available to us, or that is more readily available to us than other information. Just stop and think about what factors lead us to thinking that great white attacks are really dangerous, or the great white attacks are common, and what leads us to think that Australia has this great white shark problem, right? Stop and think about that for a second. Here, I'll give you the answer now. So, we have movies like Jaws, and The Meg and all these other kind of fantastical shark films, 47 meters down and so on, right? And so usually our interaction with information relating to sharks involves dangerous, aggressive sharks. So that's the information that's most available to us. We watch those films more often than we watch documentaries on sharks, for example. Now, my second question, why do you stereotype Australia as having a great white shark problem? Well, how often do you actually hear news from the continent of Australia? Not all that often, right? And when you do hear news from Australia, you're going to hear news that is a little bit more sensational and, attention grabbing, right? News that had to make it all the way over across the Pacific Ocean to the shores of America, right? And not all information is going to make that leap. And only kind of the salient, attention-grabbing information is really going to traverse that journey. And, a shark attack, that's a pretty attention-grabbing piece of news. So that's something that might actually make it to American shores. And then the information that you actually have available to you, I want to emphasize this availability element, that contains a disproportionate amount of information about dangerous sharks. I have this exact same problem when I speak to my Australian friends and relatives about American politics, because they have they often have very naive, uninformed views based on a few little snippets from the news, and I have to explain to them, no, it's a lot more complex than you think. There's so much more going on, and try not to make judgments based simply on the information you have available to you, because I can attest that that information that you guys get over there is a little bit limited in some ways. So, okay. Let's have a look at the availability heuristic in how people estimate the causes of death. And obviously, estimating the cause of death, that affects a lot of decisions we make. Do we fly or do we drive? Do we what sort of mode of transport we take, right? That's one obvious example. All sorts of other decisions, you know, is it safe to go scuba diving, excuse me, you know, is downhill skiing safe, or am I going to expose myself to injury, and so on? Am I allowed to have one glass of red wine every night, you know, and so on and so forth. So these estimates, the judgments that we make about things like causes of death are really important in the decisions we make. So the heuristics we have that influence our estimates are really important to look at as well. They're a little bit more foundational. They lie beneath the surface of what's influencing our decisions. Okay, so what do we think is more likely? Death from homicide or death from diabetes? Death from car accidents or death from stomach cancer, and so on. So 27% say homicide is more likely than diabetes, 81% say car accidents are more likely than stomach cancer, 65% say shark attacks are more likely than death from a falling airplane part. Well, it turns out that the true ratio is actually rather different. So homicides versus diabetes, participants, sorry, my mouse is probably not lined up correctly, I'll do my best here. Homicide versus diabetes, participants were close, 27%, when really they should have said 16.7%, because a 1 to 5 ratio, 16.7% would be 1/6 of all such deaths. Homicide occupies about that much, but participants thought it was about 27%. Car accidents, right? The true ratio, more people die from stomach cancer, and airplane planes is the really surprising one, right? You're much more likely, 30 times more likely to die from falling airplane parts than to die from a shark attack. Now, that doesn't mean that you really, really need to worry about falling airplane parts. Really, it just means that you don't need to worry about shark attacks, right? Both of these are extremely unlikely, and shark attacks, death from shark attacks is so unlikely that it's even 1/30th as likely as something as rare even as falling airplane parts. So as you can see, we make decisions that are incorrect, or judgments rather, that are incorrect, and we do so largely because we have certain information that is more available to us than other information, right? We've heard about shark attacks more than we've heard about airplane parts killing people, for example. Now, we have some other ramifications of availability heuristics, right? So remember, we're making judgments based on the information that is most readily available to us. And that information that's readily available to us might not be all that accurate. So a couple of consequences of this, we have illusory correlations. We often assume a correlation between two phenomena that kind of go together. But maybe the correlation isn't real, or the correlation is much weaker than it is assumed. Now, here's a website that I recommend you check out. The PowerPoint slides have been uploaded on Canvas, so you can check them out there. And this website shows all sorts of really ridiculous correlations between two variables that really should not be correlating at all with each other. So I believe there was one correlation whereby over the last few decades, the rate of cheese manufacturing, the amount of cheese manufacturing in the country, positively correlates with the rate of people strangling themselves to death with bed sheets, right? Now, cheese and bed sheet strangulation, those two things obviously have no conceptual or meaningful relationship, but for some reason they have a statistical relationship. That statistical relationship is probably completely spurious. There's no actual causal or meaningful relationship between them. They just so happen to be statistically correlated for, there could be a million different reasons. You've all heard correlation doesn't equal causation. That's pretty much what we're talking about here. Another classic example, it turns out that the amount of ice cream that we eat positively correlates with how often people drown. Now, what's the third variable at play here? Why does drowning go up as ice cream consumption goes up? Think about another variable at play. Well, that variable might be time of the year. Is it summer? Is it winter? People go to the beach more often in summer and they drink more ice cream in summer. So it's a third variable, season of the year, that's explaining it. Or maybe temperature. In hot climates, they eat more ice cream and go swimming more often than in colder climates. Anyway, let's look at stereotypes. I mean, we've talked about this already, and you'll have some idea of what this is. It's an oversimplified generalization about a social group. And it often focuses on the negative, but some stereotypes are positive. Positive stereotypes can actually be very harmful, right? So I'll give you an example. There is the quote-unquote positive stereotype that black Americans are tougher than white Americans, right? More athletic, stronger, more resilient, they've been through more hardship, right? I mean, that's a pretty positive stereotype for me. Maybe some people disagree, but that quote-unquote positive stereotype has been implicated in explaining why black patients in the ER sometimes get lower dosages of pain medication than white patients. In some cases, it might be that the ER doctor is bigoted and prejudiced, although I tend to doubt that explanation. I think it's the positive stereotype at play that's actually more of a culprit. The ER person is subconsciously thinking, oh, this person is tough, they don't need as much of the drug, right? So even positive stereotypes can be harmful. And here's another example for you. All lawyers are greedy. An example of a stereotype. This one is negative, obviously. Here's another heuristic for you. And this one I think we've covered already, actually. Something like this. Imagine a man is admitted to the hospital and he is complaining of chest pains. And that's the main reason he's admitted to the hospital. Now, ask yourself this. Which of the following two options is more probable? He is more than 55 years old, or he is more than 55 years old and smokes. Now, what is the stereotype telling you? The stereotype, or this, social heuristic, this mental shortcut, is telling you, oh, people who have smokers have are more likely to have chest pains, right? People who smoke are more likely to have chest pains than people who don't smoke. But does that mean that people who have chest pains are more likely to smoke than people who don't have chest pains? Not necessarily. People have chest pains from all sorts of factors, right? So what we have here is the stereotype of smokers usually have chest pains influencing your judgment of probability here, right? The correct answer is older than 55, because you have these two social categories, right? Some people are older than 55 and some people are smokers, and then there's an overlap with that category. Some people are both older than 55 and smoke, but you look at the size of each field that we're looking at here, right? There's a lot more people who are older than 55 than there are people who are older than 55 and smoke. It's much more likely that somebody's only older than 55 than somebody's older than 55 and they smoke. So even though this patient came in with chest pains, and even though this person, we're guessing they're over 55 years old, it's still more likely that they do not smoke. And the stereotype is what is leading us astray, leading us away from sound, logical, statistical judgment. Here's another example for you. I believe we may have covered this, but that's fine, because this example really reveals the role of prejudice and negative stereotypes a little bit more than the other one. Okay, Linda is 31 years old, single, outspoken, and very bright. As a student, she was deeply concerned with issues of discrimination and social justice, and she also participated in anti-nuclear demonstrations. Which is more likely, Linda's a bank teller, or Linda is a bank teller and is active in the feminist movement. So you should know by now that the first answer is more likely. The second answer involves a subcategory of the first, right? Some bank tellers are also feminists. It's a subcategory, right? Okay. Now, I think I got the ordering of these a little bit wrong just now in my preamble. This next, the next one coming up is it represents a little bit more negative, hostile, prejudicial judgments. But anyway, that example coming up, these examples all reflect what we call the representativeness heuristic. Something represents a broader category, right? Something is an example, an exemplar of a category. It is representative. It has representativeness of a broader category or group. So here, Linda seems like a representative feminist, but not a representative bank teller, right? So it's a feminist stereotype that is leading you astray from sound statistical reasoning. Likewise, with age and smoking, smoking seems to be representative of a representative case of a heart attack, right? We think about people who have heart attacks or are suffering chest pains. We think, oh, a smoker is representative of that category. Now, here is the example where we touch on actual prejudice. Richard is 31 years old. On his way to work one day, he accidentally backed his car into a parked van. Pedestrians were watching, so he got out of his car. He pretended to write down his insurance info, and then he tucked the blank note into the van's window, got back into his car, and drove away. Later the same day, Richard found a wallet on the sidewalk. Nobody was looking, so he took all of the money out of the wallet, and then he threw the wallet back in the trash can. What is more likely? This is what participants have to answer. Richard is a teacher, or Richard is a teacher and fill in the blank. That's when the second category is added, right? Now, what the researchers did was they gave different participants a different second category. Everybody that read that Richard is a teacher, or Richard is a teacher and blank, but the researchers varied this XXXXX, or the blank, to be different social categories depending on what group participants were randomly put into. So, this is research by Will Gervais, by the way, at University of Kentucky. And then the dependent variable was how many participants made the conjunction error, right? How many participants chose option B? That is what the dependent variable is. Because option A is the correct option. Option B is always the incorrect option because it's less likely. Richard might be a teacher and a whatever, but it's less likely than Richard just being a teacher. So how many people made the error? Well, when the second category was Christian, very few people made the error. When the second category was Muslim, a few more people made the error, but still very few. Still, only 17, 18%. Statistically, not significantly different from the Christian category. What about when the target was a rapist? Obviously, a very immoral social group. By default, they are immoral, dangerous, evil, unethical, and so on, right? Well, now we have over 40% of participants making this error. By the way, these bars that you see, these are standard deviation bars. So the average distance of each participant from the mean of that participant group, right? So rapists, obviously, when we think, oh, Richard is a teacher and an atheist, that stereotype Richard is a teacher and a rapist, that stereotype of rapist activates stereotypes of immorality, and that leads us to, that biases us away from good logical statistical thinking. Okay, what about when that category is atheists? Good God, it's even higher than the rapist condition. Even more, I mean, it's not statistically significantly different, but still, statistically roughly the same proportion of participants in this condition, almost 50%, felt that this immoral person was more likely to be a teacher and an atheist than just a teacher, suggesting that for them, this atheist category really evokes notions of immorality. Atheists are representative of this social category of immoral people, right? So here we see how biases in our heuristics and our stereotypes can really lead us to negative and harmful views. Okay, so Will Gervais followed this up with some subsequent research, and he found that it didn't matter what the type of moral violation was. Like, did Richard steal, or did he, did he not leave a proper note in the van's window, right? Or was Richard a serial killer, something really serious? Here we still see that atheist stereotype is activating this representativeness heuristic of immoral people. We even see it with scenarios that depict incest, a different type of immorality. We still see this strange bias that atheists are just generally seen as representative of immoral people writ large. Now, a bit of a side note, there's some evidence that religion does promote prosociality, and it's usually like, oh, on Sunday people will give a bit more to charity, or like if I give you a questionnaire in front of a church, you're less likely to cheat and lie and that sort of thing. But by and large, atheists as individuals are not necessarily more immoral than religious believers, and there's really not much evidence at all to suggest that atheists are morally deficient or anything like that, right? So these stereotypes, I want to clarify, are not accurate as far as the evidence suggests. But it's kind of scary that participants around the world were responding to this type of study in this particular way. There's a subconscious stereotype that atheists are immoral. Even some atheist participants have revealed this particular effect. So that's how insidious and deep the stereotype is in our culture and our psyche. Another example, what if I tossed a coin and I got 3 heads in a row? Stop and think about what the probability of that would be. Well, the answer is 0.5 times 0.5 times 0.5. So half times half is a quarter, half times a quarter is an eighth, so we're looking at 0.125 likelihood that next that we would get 4 coins in a row, right? Is that correct? Well, no, because all I asked was, what is the likelihood that the next coin will be a head? Well, maybe I didn't ask that, but that's what I'm asking you now, right? What's the likelihood that the next coin is a head? No, it's not 1/8. The likelihood of getting 4 coins in a row is 1/8. The likelihood that the next coin will be a head is 50%. What happened before does not affect the probability of what comes after. Well, that's factual, but does the average person recognize that, or are we biased? And do our biases lead us to bad judgments and bad decisions? Objectively, the likelihood is 50% that the next coin will land on heads. But if you've seen three heads in a row, you might start thinking, oh, this is a weird coin, or something's going on, right? So with this example, we can see that heuristics affect our assumptions of processes, right? This is a process. Does the coin land on heads or tails? And tossing a coin and so on. So we see 3 heads in a row. This is not representative of a random process, right? This is more representative of a fixed process or a predetermined process, right? And so subconsciously, if not consciously, we're thinking, this is not representative of randomness. I am not going to rely on this 50-50 probability judgment that I usually rely on when I think of whether a coin's going to land on heads or tails. And we see when participants are betting money on the next toss in this kind of in a fictitious scenario that researchers would put together in a lab, right? Most people, luckily, say, okay, it's roughly roughly 48% of people, roughly half of participants have no preference, so they are accurate. They recognize, it's 50-50. Why would I bet either way? 8% bet on heads. So that's a small number, but 44% bet on tails, right? So it seems like for this 44%, they're thinking subconsciously they're thinking, hey, this is not a random process, and sooner or later there's got to be a tails. And the more heads that I've seen, the more likely that it is that I'm going to see a tails soon, right? That's the logic that's probably going on subconsciously in these participants' minds. When in reality, I mean, 44% is a whopping number of people, whopping proportion of people making an incorrect judgment and decision. Only 48% of people thereabouts correctly make no preference. Okay, now, one of the reasons why we stray from sound statistical logic is our failure to recognize base rates, right? So earlier I gave you the example of a patient being admitted to the hospital with chest pains. And you're thinking, your stereotype is activated, chest pains, 55 years old, whatever, maybe he's a smoker. Smokers have a lot of chest pains. But you're ignoring the base rates, which means the rate of a particular phenomenon in the entire population, right? It's base, it's foundational, that's the foundation, and above that foundation we might be looking at, you know, certain populations here and there, right? But at base level we can look at the actual rate of a particular phenomenon in society, in the overall population. So, at Cloverdale High School, 10% of the seniors go on to college. Bob's a senior at Cloverdale High School. He gets mostly A's and B's in school and is well liked by his teachers. Given what we know, what is the most likely probability that Bob will go to college? Now, there isn't a concrete, like, objectively true answer to this question, but some answers are more likely than others, right? And what information are we actually looking at? That's the key here. I would guess that most of you, well, maybe not most of you because you're a little bit more savvy now, but most people would look at A's and B's and think, oh, okay, relative to his cohort, he's really elite, he's going to do well. But most people, in doing so, will disregard the base rate. The general rate of his population, and focus on the diagnosticity of his particular case, right? We're focused on Bob. Oh, Bob seems really intelligent. Okay, but what population has Bob come from, and how does that population usually behave? What usually describes that population and the people from it? Well, only 10% of that population go on to high school. We don't know how Bob's cohort performs. Maybe most of them get A's and B's in school. We don't know that information. All we know about the base rate, about the general population from which he comes, is that only about 10% of seniors go on to college, which means that for our purposes, the most likely, without knowing any further information, we could be wrong, but simply given what we know, the most likely answer is 10%. Let me give you another example before I go on to this example. Imagine I described to you a person, John is quiet, he wears glasses, he's introverted, and he really likes to read. Now, what is more likely? John is a librarian or John is a farmer? Well, it turns out the correct answer is John is a farmer. Now, some of you are probably thinking librarian because of the stereotype I described to you, right? John wears glasses, he's introverted, he likes to read, and so on, right? But what we're ignoring from this description, the information that we don't have here, is the base rate, or are the base rates of each group in society. It turns out America has a lot more farmers than librarians, right? So when you have way more farmers than librarians, it doesn't matter how I describe an individual person, short of describing them as a farmer or a librarian, already at base rate, at the foundational level, it is much more likely if you randomly pluck up somebody from society, that person is going to be a farmer, and more likely to be a farmer, and less likely to be a librarian. Any additional information I provide, he's introverted, wears glasses, likes reading, and so on, is less informative than that base rate. And that's what's important. The base rate is among the most informative pieces of information, but we often forget it, we often neglect it, or don't even think about it. Another example of base rates and kind of ignoring statistical patterns is the fact that sample size matters. So have a quick read of this while I catch my breath. Okay, so for a period of 1 year, each hospital recorded the days on which more than 60% of the babies born were boys. So atypical days, right? Kind of like error. They deviate from the norm, right? Which hospitals do you think recorded more such days? You can choose about the same, or you can choose one of the two hospitals. So stop and think about this for a second, and think about the importance of sample size, right? If I ran a study with 15 participants and drew some conclusions from it, how would you think about my conclusions compared to a study I ran that had 1,000 participants? Obviously, the study with 1,000 participants is going to be closer to the population at large, right? The larger the sample, or in this case, the larger the hospital, the more it will resemble actual reality of the overall population. Hence, the larger the hospital or the larger the group, the less likely we will see abnormal or atypical events, right? Which means that the correct answer to this question is the smaller hospital. So this is what we call the law of large numbers. Larger samples are objectively more representative of the population because literally there are more members of the population in that sample, right? A little bit of a tangent, when we're looking at statistical analysis, and you might be familiar with p-values, p is less than 0.05, p-value just means if in the real world there's actually no effect to speak of, what's the likelihood that I would find an effect in my sample? If that likelihood is less than 5%, then I say, okay, my sample probably does represent the population because I did find an effect. The chances of me finding an effect in my sample with a population that doesn't have an effect are so low, p is less than 0.05, that I'm going to assume that my sample does represent the population, and therefore I found a significant effect in my sample. That significant effect probably also occurs at the wider population, regardless of which sample I choose, right? Now that p-value is going to go down and down and down the larger your sample, because your sample, as it gets larger, is approximating the actual population more and more. So the chances that the findings of your study will generalize to the general population will increase as your sample size increases. So one of the ways that p-values go down is by increasing the sample size, which is one of the reasons we can't just look at p-values, right? Because if I'm looking at, if my sample is the entire population of America, then every single research question I ask will have a p-value of less than 0.05 because our sample, quote unquote, is just so enormous that organically that p-value is going to go down. Okay, now, simple question for you. What's the rule? 2, 4, 6? Most of you will say 8. Now, in reality, the answer could be 5, it could be 7,023,023, right? I haven't actually established a rule. You're just using heuristics to figure out what the next number is based on the most likely rule behind this sequence of numbers. So let's look at rules, so to speak, of logic and how we make judgments and decisions in relation to those rules. So, this is an example. I tried to give you this in class a few weeks ago, and it had varying success, I think, because I wasn't able to explain too much at the time to make sure that that we got some interesting results that weren't biased by you knowing about the study beforehand. But anyway, let's go through it here. This is the original version of that card sorting task that we tried. It's called the Wason selection task. So participants see 4 cards. Now imagine these cards are actually cards in front of you, right? And each card has 2 sides. So this A card has a back. This one card has another side. And on that other side is another digit, right? On the other side of the A card is a number. On the other side of the B card is a number. On the other side of the 1 card is a letter. On the other side of the 2 card is a letter. And so there's a rule that says that when we're, when the manufacturer is making these cards, they have to follow this rule. If there is a vowel on one side of the card, there has to be an even number on the other side of the card. And if I see a vowel on one side of the card and an odd number on the other side of the card, then that's violated the rule and we have to throw this pack of cards out and we have to make a new pack of cards. Imagine that's the rule. It's a silly rule, right? But whatever. We're focusing on logic. It doesn't have to be real world. So, which 2 cards, there are 2 cards you need to flip over to see if the rule has or hasn't been violated. Which cards do you flip over to make sure, okay, good, the rule hasn't been violated, we can go ahead and proceed with this pack of cards. It does satisfy the rules that we came up with for whatever reason. So, which 2 cards do you flip over to see if the rule has or hasn't been violated, right? So remember, there's a vowel on one side and an even number on the other side. So, you would obviously turn over A, because there's a vowel on one side, you want to see what's on the other side. Is there an even number or an odd number? And then turning over that card would tell us, okay, have we violated the rule, yes or no? Now there's one more card we have to turn over, right? The rule is vowel on one side, there has to be an even number on the other side. So we might be tempted to turn over the card that has 2 on it, because we see in the description even number, right? Okay, we turn 2 over and then we see either A or B and we see whether that violates our rule. But does that actually violate the rule? Does that actually test the rule? The rule doesn't say anything about if there is an even number on one side, right? It only says if there's a vowel on one side, there has to be an even number on the other side. But it doesn't say that if there's an even number on one side, there has to be a vowel on the other side, right? So actually, this card over here with 2 on it doesn't matter for testing this rule. The card that matters and the card that most people don't pick is the card with 1 on it. Because if we turn this card over and it has B, well, that's fine. But if we turn this card over and it has A on it, well, then we've violated the rule. There is a card with a vowel on one side and not an even number on the other side. So, the correct cards you have to turn over, A and 1. And the reason why this is such a valuable research tool is that most people choose incorrectly, right? Most people choose the card with 2 on it instead of card with 1 on it. Now, we can vary what's on these cards and see, oh, when do people get it right? And when do people get it wrong? Then we can use that as evidence to suggest that, okay, maybe people have certain heuristics, mental shortcuts. And when the cards have some sort of information on them, then that information activates those heuristics, those mental shortcuts. Whereas here, with this layout, it doesn't seem to be activating our heuristics and we don't perform very well on it. Let's give some examples of this. So ultimately, what we're talking about here, we're drawing on information from evolutionary psychology in part, because it turns out that some instances of a logic are easier to detect than others. What we put on those cards will help determine whether we get the task right or wrong. So under evolutionary psychology, it's a little bit of a tangent here just to prepare you for the example I'm about to give. We have evolved abilities that might help us determine the underlying logic of a particular situation. So here's an example. This is the example I tried to give you in class, right? So the rule is, if a person goes to Boston, they always take the subway, right? So now you already can figure out, okay, I need to turn over Boston. I don't need to worry about Arlington because you can get to Arlington however you want. And then you might be thinking, oh, I should turn over Subway because because the description says Subway, but now you should know, no, Subway doesn't matter. I can take the Subway to Arlington, it doesn't matter, or Subway to Boston. What matters is cab. If on the other side of cab it says Boston, then I've violated this rule because the person's gone to Boston with a cab, right? And so this is an example of this, and most people get this wrong. Roughly only 25% of people get this right. Now what about this one? The legal drinking age is 21. Which cards must we turn over to see if anyone violated this rule? Immediately the right answers are just jumping out at you. They're just popping out at you and you can't ignore them. And if you're not getting it right, don't worry. Like I said, you might be distracted or tired or something like that. But more of you will get this right than the previous one. And that's exactly what research shows, right? So we know we don't have to worry about soda. Doesn't matter how old you are, you can drink soda. We know we don't have to worry about 22-year-olds. They can drink whatever they want. But we do know we need to worry about beer because we don't want underage people drinking beer. And we do know we need to worry about 14-year-olds because we don't want underage people drinking any type of alcohol, right? So the correct answer for this jumps out at you, and it's very hard to ignore it. Most people get this correct, even though the basic methodology and the basic dependent variable is exactly the same as in the previous scenario. So, we have social heuristics, right? Heuristics that apply to the social world, right? Social rules, as opposed to, so this example I gave here, Boston, Arlington, Subway, cab, right? This isn't a social rule. This is, I don't know, an infrastructure rule, right? Is there, if you go to Boston, they always take the subway, or an economic rule, maybe it's just really difficult to get a cab to Boston, right? Or, another example might be if somebody goes to downtown Cincinnati, they always take a cab or a bus, they don't take the subway, because there is no subway, right? There's no subway taking us to downtown Cincinnati, right? So that's not a social rule, that's like an infrastructural or an economic rule that we follow, like it or not. Something can't take the subway to get to downtown Cincinnati. But this is a social rule. There's no natural law that says 14-year-olds can't drink beer. That's a social rule that we have imposed via society, right? And so these social rules, maybe these are more powerful than non-social rules. And it turns out, as far as Lita Cosmides and colleagues have shown, that people are much more likely to get this card sorting activity correct when the scenario involves cheating a social rule than when it involves, violating a non-social rule. So it seems like when the rule is social and it entails, social schema about personal responsibility and social roles and social hierarchy and age and, entitlements and that sort of thing, right? Young children are not entitled to drink and whatnot, and older people can drink but young people can't, and so on, right? Rules regarding the social world, they just seem to, it's like there's a key trying to find a lock in our brain. And social rules seem to be a key that fits the lock in our brain and then allows us to see the underlying logic in the scenario. So, we have built-in heuristic schema and whatnot, even arguably from evolution, that help us solve certain problems, but not other problems. Now, there's a few more examples in the lecture slides, but they basically rehash the same theme, so I'll let you explore them on your own. Let's move on to bias judgment, and then we'll wrap up judgment and move on to decision making. So, we have something called confirmation bias. You may have heard of this before. We tend to favor evidence that supports our hypothesis. We think that evidence is better, stronger evidence, is more meaningful, it's more empirically supported, and so on and so forth, right? So, for example, let's look at the stereotype that we just discussed earlier about, the stereotype of atheist immorality or something like that. Somebody with confirmation bias, when judging that stereotype, would, focus on, one or two examples of, oh, that guy is an atheist and he murdered somebody, therefore that prisoner is an atheist, therefore atheists are really evil, right? So that piece of evidence is legitimate evidence. Yes, that was an atheist and that atheist did do something bad, right? But is that the only evidence you're going to look at? You're just going to go out and find evidence that confirms your theory, and you're going to ignore counter evidence that disconfirms your theory and supports other theories. That's what we do when we engage in confirmation bias, right? So for example, if somebody, only watches CNN and never watches Fox News, or vice versa, right? If somebody only reads left of center news outlets and doesn't, dabble with anything right of center, well, then they're going to be more prone to confirmation bias because they're only exposing themselves to one set of narratives and evidence and arguments, and they're not exposing themselves to sort of full range out there. Related to that, we have my side bias, right? We are social creatures, and group identity is really, really important to us. So we support things that support our opinions and our beliefs, right? So just some visualizations of echo chambers, right? This is a huge problem that the entire world is facing right now. People are kind of siloed off into their own little groups, their own little echo chambers, right? If you're on Facebook, Instagram, Twitter, or whatever, most likely you're only seeing arguments on one side of the political aisle. And that's very concerning, because why would I only listen to one side? That makes absolutely no sense, when that one side will get some things right and get some things wrong, right? And the other side has interesting, unique perspectives to contribute and so on. But unfortunately, more and more, that's not the world that we find ourselves living in. So, really, really try to get out of your echo chamber. I really strongly encourage it. It's good for you. It's good for society. This is how a lot of us operate, myself included. We're all biased, we're all human, we're all fallible and have these heuristics and so on. I love reading and listening to things that support my opinions. It's way more enjoyable, usually, than listening to stuff that disconfirms my beliefs and opinions, unless I find it really interesting. I personally find it really interesting to challenge my beliefs and opinions. Maybe I'm a little bit unusual in that sense, maybe partly owing to being an academic. I have to expose myself to different ideas and so on. But I'm not going to deny that it feels really gratifying to hear somebody share my opinions and put good arguments forward, right? And it's kind of confronting and upsetting and a little bit emotionally stressful even to encounter beliefs and opinions that differ from yours, right? That's just a reality. It feels good to confirmation bias feels good. So we have to avoid that nice feeling. We have to try to find out how to enjoy discovering that we're wrong. How to enjoy interacting with people that disagree with us. That's the secret, and I hope you guys try to work on that. Here's a question for you. As a kid, you watched several movies, perhaps, for example, The Princess Bride, I highly recommend it, where quicksand was a serious problem. This scared you and led you to think that quicksand was a danger to society, and there's a lot of quicksand out there and we need to be careful. What heuristic is at play here? Have a think about it for a second. I'll give you the answer now. The heuristic at play here is the availability heuristic, because quicksand being dangerous is the only idea, argument, stereotype, schema, whatever you want to call it, of quicksand that you have out there. How many movies, TV shows, whatever, comic book strips or anything like that have you seen where quicksand is not dangerous? People walk on quicksand and they're like, oh, it's totally fine, right? That doesn't happen. So your only experience, interaction with quicksand is that it's dangerous, and it seems to happen in a lot of these, kids' cartoons and movies and stuff like that. So the information that is available to you when you make a judgment or a decision is quicksand is dangerous and scary and everywhere. So we would call that we would refer to that with the availability heuristic. Okay, now let's go into decision making. So here we make choices between alternatives. Now the traditional theory is the expected utility theory. We make decisions that result in the maximum expected utility, right? We want good outcomes. I would rather earn $100 than $50, right? So if I'm offered two jobs and, you know, they each like require the same amount of time from me, but one pays more than the other, well, there's going to be a lot more expected utility from one job than the other, and that's going to help me. That's going to be the main factor influencing my decision making. That is how this traditional theory argued. So utility can be anything that achieves a person's goals, you know, money, success, respect, you know, whatever it is. So this, of course, assumes that people are basically rational. Now, hopefully I've already dispelled the notion that humans are rational from your minds, because we've covered some evidence that clearly shows that humans aren't rational. Let's see if we can find some others. So this is, first of all, let's just clarify this expected utility theory outlook, right? So we can even establish, you know, equations that look at expected utility. This is very like kind of economic style thinking and modeling. So we look at the probability of something occurring and then the utility of it, right? So the utility of me winning the lotto is amazing, right? There's a lot of value in me winning the lotto. But what's the likelihood of it? What's the frequency of that lotto win, right? So both of them are going to factor into my decision-making process. And here's an example. Imagine you get you have to get paired up with a classmate for a student project, and we've got frequency information. Susie is there 100% of the time. Kelly's there 75% of the time. Susie has a value of 5, Kelly has a value of 10, right? Well, then you can just combine these inputs into the equation, and ultimately we discover that Kelly does have a greater expected utility, therefore you should choose to work with Kelly, even though Susie is in class a little bit more often than Kelly. You should take that risk because the expected utility is higher, and the expected utility factors in probability and ultimate utility. But are we actually rational? Have a look at these two jars and answer this question. If you need to retrieve a red jelly bean, which jar are you going to put your hand into? Most people say the jar on the right. I mean, just look at it, right? There are more red jelly beans. Of course, you've got a greater shot at procuring a red jelly bean from that jar, that bowl. But then what if I tell you, well, 1 out of 10 is red. There are 10 jelly beans and one of them is red. Over here, 7 out of 100 rather, are red. So do the math, right? Figure it out in your head. Well, that means that 10 out of 10 over here versus, 10 out of 100 versus 7 out of 100. Actually, the probability is higher in this left bowl. Well, so we look at the odds. It turns out that a lot of people will still pick the bowl on the right. Even though they've been given the odds, they decide, nah, you know what? I just feel like I have a better chance if there are more red beans in the bowl, right? So there's something about the way that humans make judgments and decisions that is not inherently rational, right? By rational, I mean, you know, like just calculating the odds and the probabilities and the expected utility of certain options and so on, right? You know, much like a computer would not make this mistake. A robot would not make this mistake. So why are humans making this mistake? That's a really interesting and important question if we're going to unravel the contents and the nature of human psychology. So here's another example of irrationality. This is something we can probably, a lot of us can probably relate to. You've been in a miserable relationship, you want to leave, you know you can do better. However, you look back at all the years you invested in that relationship and you're terrified to think that they were all wasted, all for nothing. Suddenly you start thinking of ways to fix the relationship. oh, she's not all that bad. We can work on this, right? Very, very common. Well, you know, at times like this, I turn to, you know, a hero of the psychology community. I do actually really like Dr. Phil, by the way, even though he's not, you know, in academic psychology, he's a bit of kind of like a pop star as well, but he's got some really interesting things to say. A little aphorism of his is, the only thing worse than being in a bad relationship for 1 year is being in it for a year and a day, right? There's just I think there's a lot of wisdom and truth in that statement, as simple as it is. And he's right? Why would you look back at a miserable year and think, oh, I wouldn't want that year to have been a waste? That year is sunk. That year is gone. That's why this picture is under C, because this is what we call a sunk cost. The cost that you spent that 1 year in that bad relationship, that cost is sunk. It's gone. You're not getting it back. So why would you spend any more time in this relationship using that one bad year as your justification? That year's gone. You're not getting it back. Focus on the future, right? But a lot of us fall prey to what's called the sunk cost fallacy. We ignore the fact that certain costs have been sunk, right? So investment that's already spent and you can't be recovered, but often we'll use it to, you know, rationalize future decision making when really it shouldn't be that important in our decision making. Here's another example for you to check out. What about emotions in decision making? So here's an example that is very common in my field of moral psychology. It's called the trolley dilemma. A philosopher, Philippa Foot, back in the 60s or 70s, I believe, put this dilemma together. And basically, here in this trolley dilemma, a runaway trolley cart is on the tracks, the driver's passed out or something's happened, I don't know, the lever's not working, and it's going to kill these 5 people. Sure, in this scenario it's weird, they're all tied up to the tracks, but maybe you can just imagine the track is running through a valley, people are walking along the tracks and there's no escape. They can't climb up the hills of the mountain. So they're going to die if the trolley continues on its way. But you're on the side of the tracks and you've got this lever in your hand and you can pull the lever and that would divert the trolley onto this second track where it only kills 1 person. So you have to make a decision. Do I do nothing and let 5 people die? Or do I pull the lever? Do I, you know, act? It's me acting. I'm culpable and responsible because of this action. And I do an action that leads to the death of 1 person, but it saves 5 people. But this 1 person wouldn't have died if I hadn't have pulled that lever. Now, what about a slightly different dilemma? Now, these are purely hypothetical, kind of ridiculous, imaginary scenarios, so just kind of bear with me. They do actually bear really interesting results in empirical research. And that was my cat who just stepped on the keyboard and made me proceed to the next slide when I didn't want to. Okay, so here we have the footbridge dilemma. This is basically the same calculation, right? Do you kill 1 person to save 5 people, or do you let those 5 people die? Only now, the way you save those 5 people is you push this, you know, large, heavy-set man onto the bridge, off the bridge, which supposedly stops the trolley in its tracks and it saves these 5 people. But of course, you've just pushed a man to his death. You've killed 1 person in order to save 5. So, what would be interesting to see is, do people respond differently to these 2 different scenarios? Let's have a look. So here's the trolley dilemma one. Here we rely more on cognition. We just weigh up the numbers, 5 versus 1, right? 5 is more than 1, hence the action is morally acceptable. But in this scenario, we have emotion, intuition kicking into gear. Our reasoning processes are arguably disrupted by a lot of this sudden rush of emotion. Right? Now it's personal, it's confronting. You yourself are actually pushing somebody to their death. This strong emotion of causing someone's death kind of cancels out that 5 is greater than 1 logic arithmetic we were just looking at. And it turns out that most people say, yes, I would pull the lever, but most people say, no, I would not push the man off the bridge, even though both involve, you know, killing 1 to save 5. So this is clear evidence that decision-making can be heavily affected by emotional processing. And this is neuropsychological evidence or neurophysiological evidence. So black bars represent responses to the personal dilemma, and white bars represent responses to the impersonal dilemma. So the personal dilemma is pushing the guy off the bridge, the black bars. And when participants were responding with these black bars to the personal dilemma, the emotion regions of their brain really fired. So it was definitely emotion that was involved in these scenarios that led participants to make their decisions. Okay, but now I have a wrench to throw in the works here, because you might be thinking, hang on, I mean, we have emotions. Emotions must have evolved for a reason. We're very emotionally driven species. We're also a very social species. Why would we have these emotions if they interfere with decision making and make decision making harder, and so on? Why aren't we just purely, like robots or machines that can make sound decisions that aren't biased by heuristics and biases and so on? Well, the answer is we're going to use an evolutionary psych perspective here. What may appear to be irrational to us in the modern world may actually have been very rational for our ancestors surviving over the last 2 million years, who had different pressures in their environment in order to survive, different social settings, different social structures, and so on, right? Our ancestral world looks very different to what the modern world looks like, so we can't just look at how behaviors manifest today and see a mismatch, right? Emotions don't seem to be helping us so much anymore in decision making, and then conclude emotions were maladaptive. They were probably very adaptive for our ancestors. Let's have a look at some examples. Try to explain these irrational behaviors, right? People who self-harm and self-mutilate to express their commitment to their religious group, right? That seems very irrational. They're exposing themselves to risks of infection and pain and blood loss and so on. But it turns out that this type of behavior is really common across all of the world's religions, because it benefits the individual doing it, because it signals to the group that they are a loyal, committed member of the group, and they can be trusted, and they do deserve favors and help and love and support and so on, and they deserve to be a member of the tribe, right? So if you can signal that to your tribe, that's extremely adaptive. You're more likely to survive than somebody else who's not signaling that. And it turns out that signaling is so important that that cultures will develop really extreme and ostentatious behaviors like this, even though you might think it's maladaptive. Turns out it's actually kind of adaptive. What about fasting? Or in religious traditions of burying our dead? Why would our ancestors, tens of thousands of years ago, want to bury their dead when they're struggling for survival day in, day out, and don't know where their next meal is coming from? Why would we fast when food has been scarce throughout most of human history, and hunger and starvation have been very common causes of suffering? Well, that's pretty irrational. Why would religions promote fasting? Well, it turns out that there are some health benefits to fasting, but besides that point, this again is another way of signaling to your group that you are loyal and committed. You are willing to sacrifice. You are willing to harm yourself to signal your commitment to the gods and the tribes and so on, right? Here's another example for you. John Wick. My memory of this movie, I'm probably getting some details wrong, but the Russian mob kills his dog, and he decides to go postal and kill as many Russian mobsters as he can find to avenge his dog. Now, that's pretty irrational, right? If Keanu Reeves' goal here is, or John Wick rather, if his goal is to survive, why would you go and find out Russian mobsters who otherwise were probably going to leave you alone anyway? I might be misremembering that detail a little bit, but anyway, right? It seems really irrational. You're putting yourself in danger to seek vengeance. That sort of thing should be weeded out of the gene pool, right? People who expose themselves to danger would be more likely to die. But it turns out that when we look at our ancestral environments, and this is a bit of a tangent that we're not going to go into too much detail on, but if you look at our ancestral environments, one thing that was really important in the small tribal groups in which we interacted was to be able to express your intentions and your desires really clearly to other people, and to make sure that other people couldn't exploit you, couldn't take advantage of you, and couldn't, render you an outcast in society. And sometimes it takes extreme expressions of emotion to convince people of your intentions and desires, right? So who are you less likely to mess with? Let's imagine you're a caveman or a cave woman, thousands and thousands and thousands of years ago, and you want to, get active with a cave woman. Let's say you're a caveman. You want to get active with a cave woman who's already spoken for. She's already taken, right? And the caveman who she's hooked up with, he's telling you, hey, you better not touch her. She's my woman, yada yada. But he's being rational and reasonable with you. You can either, face him, or you can face a caveman in another scenario who's, getting all up in your face and sticking a stick in your face and threatening to kill you and telling you he'll chase you to the earth's ends if you so much as look at his cave woman the wrong way and stuff like that. Whose advice are you more likely to heed, right? I'm going to listen to the second guy a little bit more than the first guy. I'm going to be more scared off by that second guy and his excess emotion and excess anger and vengeance and so on, right? So the idea is that if I kind of go over the top with my emotions, if I engage in my emotions a little bit too much, we might say, today, actually that signals, again, it's about signaling, that signals to the other people, whoa, this person's not to be trifled with. Don't mess with that person, right? Another example, think about how irrational love is, in a sense, right? From a purely scientific perspective, love is kind of irrational and involves, chemical processes of the brain and body. It's not necessarily, true love, and love at first sight don't necessarily make all that much sense, right? But imagine you're trying to convince somebody to stay with you in the long run. Surely it's going to be really convincing for them if you just fall head over heels in love with that person. You feel sick when you're not around them, right? You don't eat when you're not with them. You don't look after yourself when you're not with them. These strong emotions you're feeling lead you to make rash, silly, irrational decisions. You risk your life for the woman you love and all this stuff, right? Shouldn't that have been weeded out of the human gene pool? Well, no, it turns out that, we really like mating up with partners who really convince us that they love us, and they've even maybe even deceived themselves, and their loving feelings are so deep and powerful and unshakable, right? There's no logic to it. It's not rational that they're thinking and feeling and acting that way. Well, that's convincing, right? I'm much more likely to want to partner up with somebody who feels that way about me than somebody who looks at love in a rational way, right? So this kind of irrationality, as we're calling it, quote unquote irrationality, actually there's a rational purpose to it, somewhat, right? If you kind of overexpress or overindulge emotions, that signals to other people intent, capacity, ability, or whatever, right? And that signaling is really powerful for your survivability, especially among our ancient ancestors. Anyway, okay, so now we're going to conclude with another aspect of the role of emotion in decision making, and that falls under the theory called prospect theory. We've looked at expected utility theory, right? Decisions are made in relation to the expected utility of those decisions, right? And we've seen pretty clear evidence, well, actually, emotions really come into play when we make our decisions. We don't just look at expected utility and so on. The prospect theory takes that another step further. they argue, prospect theorists argue that decision making is driven mainly by our fear of losing something, right? Fear of loss looms much larger than desire for gain, in most people at least. You see some exceptions like narcissists don't really fall for that, can't be described with that description. So, loss aversion basically means losing something has more perceived impact on us than gaining something, and we have a greater fear of negative emotion than we have for a hope of positive emotion. So, for example, imagine you found $10, right? Or you gained $10. That's pretty cool. Now imagine losing $10. That feels really bad. I mean, for me, speaking personally, I would feel worse losing $10 than I would feel good gaining $10. Like, it weighs on my emotional state more to lose something than to gain something. So here's some evidence, just one piece of evidence. There's plenty of evidence. This is one example. So participants were brought into the lab, and they were handed a mug, and half of them were given this mug, and they were told, "This is yours to keep." The other half were given this mug and told, "This is yours to evaluate." Right? So there's no possession, no ownership. You don't own this. It's just this here for you, right? But one group, they have something they can now lose. Right? They own something. They've been given something. It's now in their possession, and now they have something that they could possibly lose. They're asked to place a value on the mug. Well, the whole point of prospect theory is, do we value loss? Does loss pose a bigger concern for value than does gain, right? Does losing something affect value more than gaining something? So it makes sense that they're asked to place a value on the mug, and it turns out that the group who were told they get to keep the mug, price the mug at a much higher price than the group that were told they just have to evaluate the mug. So this simple variable, did you have something to lose, yes or no, was all it took for this big difference in evaluation. So the expected value theory or expected utility theory would argue that the more you gain, the more value there is, right? It goes up like that, and then the more you lose, the less value there is. And it's a perfect linear relationship. By linear, we just mean a straight line. As one variable goes up, the other variable also goes up, or down. If it was going down that way, it would be a negative relationship. But as per the uber cognitive psychologists Kahneman and Tversky, Kahneman is still around, Tversky sadly is not. Kahneman won a Nobel Prize for economics, actually, for this work and other such work. Tversky might have won one as well, actually, I just realized. But anyway, this is the point, right? As gains increase, and what sees x-axis as gains increase, the subjective value starts to flatten out. It doesn't just keep going up and up and up, right? If I win $10 million in the lottery, well, what difference does an extra 1 million make? 11 million versus 10 million doesn't really affect my happiness, right? But if I go from $0 to $1 million, man, that's going to really affect my happiness and my ability, my decision-making ability, and so on, right? So that first million counts a lot more than the 11th million. Eventually, you get to $1 billion. What's an extra million? Doesn't matter at all. Doesn't increase any value to you. Losses, it's the inverse, right? In a sense. So I don't have to lose so much in order to really experience a massive drop in subjective value. So for example, the losses here of the same monetary amount lead to a faster decline in value than the gains lead to an increase in value. Okay, now I've showed you this stuff on context and decision making already with the C section, so you can go back and check that out in your own time. and framing with organ donations, we covered that. And there's a little bit more information here about framing. The slides are on Canvas, so I'll let you check this out in your own time. Lotteries versus gamble, just a little bit of extra information on this topic, but we've covered the important points. In summary, we could summarize by asking, why did Daniel Kahneman, a psychologist, win the Nobel Prize in economics? Well, first of all, there's no prize in psychology, but also human decisions are not always rational, and this includes economic decisions, monetary, financial decisions, what people purchase, how people make decisions about insurance. These really important decisions that we make in our lives, right? Economic decisions are fundamentally questions of human psychology. What leads us to make certain decisions over other decisions? Humans make mistakes, but the mistakes are predictable if we understand human cognitive psychology and also human evolutionary psychology and various other domains of psychology. Well, here is a summary of the key concepts that we've looked at. So take some time to learn these terms, and as always, contact me if you have any questions. All right, thanks for listening.